Hey, what's up everybody? It's Dan from SageMathTutoring.com, and I am parked by the side of the road on a beautiful day by the beach, so you might hear some noise in the background because there's people around. And nonetheless, here is a new video that has to do with simplifying these kinds of fractions here, and it's for a student of mine who could use a little help, and that's what this is for. So write the fraction in simplest form, state the restrictions. So when they say state the restrictions, they mean make sure that you're clear which x values would cause the fraction to be undefined, and therefore make sure you are clear which x values or which values are such that x cannot equal. All right, so for example, in something like this, if x was 1, well, x minus 1 would be 0, and therefore the denominator would be 0, which would cause an undefined fraction, and that is against the rules. You're not allowed to have undefined fractions. So for example, just stick with this example actually. When it comes to this one, the restriction would be literally that x cannot be, I'll write it in yellow, x cannot be 1. Because of this, and also because of this. Okay, so that is already the restriction for number 5, but let's do one at a time here, starting with number 1. So if we're going to figure out what the restriction is for this one right here, you could always force x squared minus 5x to equal 0 first, and just kind of solve for x to figure out what x ultimately is not allowed to be, because x is not allowed to be the number that would cause the denominator to be 0. So in order to solve this, it would be x factored out, so you have x minus 5 equals 0. So therefore, hopefully y'all can see that x is not allowed to be 0 and x is not allowed to be 5. So therefore we can write that down. We can say x cannot be 0 or 5. And as far as actually simplifying this thing, well, actually factoring is a good idea in the first place. You're going to want to factor the bottom and you're going to want to factor the top. So I'm going to do that right now. We'll blow this up a little bit. So factoring the top gives us 2 times x minus 5 all over x times x minus 5. And of course this cancels, and therefore we have 2 over x. And unless I made a careless mistake, which is always a possibility, that is the simplest form of this fraction, therefore. So that's that one. Moving on. Alright, so let's do the exact same thing. We're going to temporarily do a separate problem, or a separate equation, where we set this equal to 0, find out what x is, and that will show us what the literal restriction is. So anytime I do these sort of separate problems off to the side, I'm going to use yellow. And I think it's important to keep in mind that this is not really the problem itself. This is more just a separate investigation that allows us to figure out what the restrictions are. And by the way, this would factor to x plus 4 squared equals 0. So therefore we know that the restrictions are, we'll color code this, the restrictions are, imagine this was written in red. I'm going to make it so that the restrictions are always written in red from here on out. So we have x cannot be negative 4. And as far as the problem itself, we are looking at the numerator right here, which would totally factor into the following. 4, 1, we'd have plus, we'd have minus, and then down below we have x plus 4 squared, which is really just x plus 4 times x plus 4. And of course these cancel, and you are of course left with this, where it's x minus 1 up top and x plus 4 down below. That is the final simplified answer for problem number 2. Moving on. Perform the indicated operation, state restrictions. Okay, well, the restrictions here are very easy to deal with. Clearly, x is not allowed to be 5. X is not allowed to be 5. And as far as adding these, that's going to be simple because we already have the same denominator, which is all you need. You need the same denominator in order to add fractions. So we're going to do what you typically do, which is to simply keep the denominator and add the numerators, which we totally just did, and we're done. It's actually all there is to it. Okie dokie, stating the restrictions here. The restriction is fairly easy to figure out. X clearly is not allowed to be 0, and x clearly is not allowed to be positive 2. So x must not equal 0, 2. Now we want to perform the indicated operation. Well, that's multiplication. Now multiplication, always straightforward when it comes to fractions. You could always just multiply straight across, which is great. Many of you know that often it's the case that you could do a cross cancellation to make your life easier in the future. I say let's do that because there is an opportunity to cancel this x with this x. So we're going to cancel that x with this x, and we are going to totally multiply straight across from there. Now when this cancels, it becomes 1. When this cancels, it becomes 1. So therefore what we have is 2 times 1 and 1 times x minus 2. Of course the 2 times 1 is just 2, and the 1 times x minus 2 is x minus 2. Once again, hopefully did not make a careless mistake, but I'm pretty sure that's it. Okay, so that's that one. And we already did the restriction for this one. I'm going to wrap it in red because red for restriction. Once again, going to be pretty easy. We already have the common denominator, so we could just keep the denominator and multiply, or add, I should say, straight across. When you do so, you end up with keeping the denominator and adding x squared plus 2x plus x minus 4 up top, and simplifying that would give us, of course, x minus 1 on the bottom. Nothing changes about that, but up top it would be x squared plus 3x minus 4. Boom! That is totally the answer to that one. And yeah, that's as simple as it could get because, let's see, x minus 4 wouldn't cancel with x minus 1. This would be x times x plus 2. Yeah, so this is as simple as it could be. I suppose it might have been actually smarter for me to factor x out here to turn this into x times x plus 2 first, just to double check and see if I can cancel one of these factors with the denominator. As it turns out, I can't cancel anything up here with the denominator, so it turned out that there's no cancellations here, and therefore this is actually the simplest form. There's no cancellations that can take place here either. Okay, so I'm going to screenshot this photo right now, and we're going to move on to the next page. Alright, I totally screenshotted it, and now I'm actually going to get rid of that. And we have another thing here. We also have my logo, which rules, right there. Alright, as far as this thing, once again, multiplying straight across, although there might be opportunities to do a cross cancellation. Now, and I'm indeed seeing that you can do a cross cancellation because you can cancel the 4 with the 8, or at least do a reduction there, and then you could factor out 2 up here, and that would result in a nice cross cancellation as well. So we're going to do that right now. So let's turn that into a 4, or I should say into a 2, really, because 8 divided by 4 is 2, 4 divided by 4 is 1, and this turns into this. And you know, the x plus 6 would cancel with the x plus 6. So that's a beautiful thing. We're about to multiply. However, once again, we do not want to forget to state the restrictions. Now, since this is x plus 6, if x was negative 6, this would be 0, so x is not allowed to be negative 6. Since this is 4x, if this x was 0, then 4x would be 0, and therefore x is not allowed to be 0 either. And from here, we again, we already did the cross cancellations, which is great. So we have 2 times 2, which is 4, so that's going to be a 4 up there. So we have 4 at the top, and then we have this turned into a 1, and then you have 1x, so you just have an x down below. So that should work. All right, that was problem number 6. Problem number 7, I'll actually keep starting with the restrictions. It's good to be consistent in what order you do things. So we'll say x is not allowed to be negative 5, and x is definitely not allowed to be 2 for all of the aforementioned reasons. All right, so this is the first time where we're asked to add fractions that have different denominators, so I'm tempted to sort of find the common denominators here. Now, the common denominators here are, I should say, the common denominator that we should use is the LCM of the two denominators. What is the least common multiple of x plus 5 and x minus 2? Well, my student at home hopefully knows, do a little divider here, hopefully knows that the LCM, and therefore the good, common denominator that we could use, sometimes they call it the least common denominator, in fact I'll call it the LCD, least common denominator, is literally going to be x plus 5 times x minus 2. So in other words, we want to turn this entire denominator into that, and we want to turn this entire denominator into that. So you have to ask yourself, okay, if I want to turn x plus 5 into this, what do I have to multiply x plus 5 times? Well, clearly, you have to multiply x plus 5 times x minus 2. But I'm not allowed to multiply the bottom by x plus 2. I also have to multiply the top by x plus 2. So we have x minus 2 and x minus 2. So I mean x minus 2 in case I said x plus 2. Then we have x minus 2 over here, and we have x plus 5 because that's what's missing. And then we're going to have x plus 5 over here. And as a result of that amazing work, we are then going to have this whole thing on top, and we're going to have just this on bottom, right? Because it's the same denominator now on bottom. So we could totally just use that as the denominator. So when I do so, I end up with that down below. Now I'm actually going to leave it in factored form for now. X minus 2 times x plus 5. That's what's below. But then we have to sort of bring all this. So we have 3 times x minus 2. I'm actually going to get this over with right now. 3 times x minus 2, that's going to be 3x minus 6. So we have 3x minus 6. And over here, we're going to have 4x plus 20. So we're going to have plus 4x plus 20. I do want to be careful because had this been subtraction, it would have been negative 4 times plus negative, whatever that is. And simplifying the top is the next step. Now, let's see, simplifying the top, we have 7x plus 14. And I can see already that this would factor into a 7 times x plus 2, which would not cancel the x minus 2. So believe it or not, even though this looks factorable or is factorable, and it seems like it's such that you could cancel something with the bottom, you're not going to be able to, because x minus 2 times x plus 5 would not cancel with x plus 2 up here. So we're kind of stuck with the denominator as is and the numerator as is. I'm going to go ahead and FOIL this and make it x squared. I know this is going to be a negative 10. That's kind of how I like to do FOIL. And then we're going to have a positive 3x in the middle. And again, unless I made a careless mistake, that is definitely the answer there. Okay, so this is number 10. I don't know if I want to do number 10 yet. Number 8. x plus 2, x plus 7. It could very well be a similar situation, you know, like we just did. Before we get into it, let's get into the restrictions. X is not allowed to be -2, and it's not allowed to be -7. Okay. This would factor into 3 times x plus 7. And this x plus 7 cancels with x plus 7 here. And this is actually multiplication. At first I thought it was addition, but it was multiplication. So that cancels there, which is great. There's no cross cancellation that can take place here. So this one's just going to be 3 times this whole thing. And x plus 2 times 1. Now I'm going to get rid of this thing because it's kind of distracting and we don't need it. We already turned this into that. So we're going to have 3 times that, and that's going to end up giving us, let's see, 3x minus 24, and that's going to be over x plus 2. And that right there is going to be the ticket. All right, hopefully that makes sense. And let's see, this one, first of all, the restrictions, of course, are going to be x cannot be 1 or -9, and that's due to these guys and also this guy. Now, to find the common denominator, again, you need the least common multiple, also known as the least common denominator. So we have x minus 1 times x plus 9. This one already has the common denominator that we would want. This one is lacking a little bit. So in order to turn x minus 1 into this, then we would have to multiply the top and bottom by what's missing, which is x plus 9. So when we do this multiplication, we're going to have to be very careful because the reality is it's a -3 times that, all right? So, you know what? We're going to take care of that in a second. Let me just put what will be our denominator down here, which is going to be x plus 9 times x minus 1. I mean, that's for sure. We know that we're going to have that, right? But we're going to work the numerator out now. Certainly we're going to have a 5. But then we want to be careful. -3 times x is -3x. So it's going to be -3x. And then -3 times +9 is -27. So it's going to be a -27. So then, of course, from there, we are going to end up with something a little bit more simple called the following. Let's see, the 5 minus 27, that's -22. So we're going to have -3x minus 22. And with regards to the bottom here, if we were to FOIL that out, we would have x squared. We'd have a -9 at the tail end. And 9x minus x is going to be 8x, so that's going to be 8x right there. And that actually is the answer at that point. There's no cancellations that could take place here because -3 and -22 do not have any common factors other than 1. So unless I made a careless mistake, that is that one. All right, focusing on the final problem, which is x squared minus 25, x plus 5, blah, 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 blah. Well, this is plus, so it's not multiplication. So it's not like I can do this cross-cancel thing just yet. The question is, if we want to add these, how can we get a common denominator? What's the least common multiple of 8x and 24x? Well, bottom line is 8x times 3 gives me 24x. So 24x is actually the least common multiple that we could use for the least common denominator. So what that means is we're going to have to sort of work with just this guy, right? Now, as usual, before we do that, I keep almost forgetting, admittedly. Restrictions: x is not allowed to be 0 because it would cause this to be 0 and this to be 0. So we want to make sure we follow the directions. The teacher tells us to do that, so we're definitely going to do that. Nonetheless, we're going to work with 8x to turn it into 24x, and the way that we do that is by multiplying the top and the bottom by 3. Right? And when I multiply the top by 3, I have to multiply the entire thing by 3, correct? So on the next line, we're going to kind of work that out. I'm a big fan of saving time, so we're going to just have 24x down below, because we know that that's what the denominator is going to be. That's what the common denominator is going to be. And let's kind of piece this together all the way across. It's going to be, 3 times x squared, which is 3x squared. It's going to be 3 times negative 25, which is negative 75. It's going to be x plus 5 over here. So it's going to be plus x plus 5. Now, we have, of course, like terms with negative 75 and 5. So on the next line, we could totally write 3x squared plus x minus 70 all over 24x. Now again, there's a chance that I got a careless mistake in there somewhere along the way, but I feel pretty good about this. I'm not sure if 3x squared plus x minus 70 is factorable. But even if it was, it would factor into two. It would factor into two like sausage links with like 3x and something over here and something over here, and none of that would cancel with the 24x on the bottom anyway. So this is as simplified as it could be, as far as I can tell. All right. Or I should say, I definitely know that it is. The only thing I'm unsure of is whether or not I made a careless mistake along the way. But time is of the essence, and I do have to move to another appointment. So I'm going to screenshot this one and send it to my client. So for those of you at home, I hope this made sense. Again, careless mistakes here and there, perhaps. Although I don't think I did, but you might catch some. In fact, if you catch some, just let me know in the comments below. But as long as you understand the process, that's really what matters most. All right. So good luck, everybody, and I'll talk to you next time. Bye.